In this video I'll solve question 4 of the Cayley Olympiad paper from 2022. The Cayley Olympiad is sat by students who've done really well in the UKMT's Intermediate Maths Challenge. It's aimed at students in Year 9 in England and Wales, or students ages 13 to 14 if you're comparing with other parts of the world. Depending which year group students are in and how well they've done, they might progress to either the kangaroo rounds or the Olympiad rounds, can be the grey or the pink kangaroo, or the Cayley, Maclaurin or Hamilton rounds, depending what year group they're in. These are some of the most challenging problems for students of this age group, and unlike the Intermediate Maths Challenge and the kangaroo rounds, the Olympiad rounds do require students to give full working in their answers. So this question would be worth 10 marks in the Olympiad round. The best way to practice for these competitions is to head over to courses.mathsaurus.com, where you can try one of my free preparation courses. So you can work through this question and all the others in this paper with video hints as well as solutions. And there are also courses for the Intermediate Maths Challenge, for the kangaroo, for the junior and senior rounds, and loads more over there as well. So do head over there, totally free to sign up, no payment details are required to access these free courses with the UKMT questions. So I hope to see you over there at some point, but for now let's get on with this question right here on YouTube. Please do like the video and subscribe to the channel if you haven't already. Now the key for these geometry questions is really big, clear diagrams, and it's worth taking a little bit of time to get those diagrams right. Doing it on the computer here, I've got the advantage of being able to use tools to draw octagons very easily and nicely, but you should try to do that just as best as you can. So we've got this octagon and it's inscribed in a circle. So if I try to draw a circle around this, and I'll try and get that as well as possible. And I think the thing that I see here is that my octagon tool has not drawn an especially regular octagon, so let's just adjust that slightly, and again much easier to get a nice picture here than on a piece of paper, but I will use the nice version for the purpose of illustration. And let's label the points here. So let's go A, B, C, D, E, F, G, H around in this order. You can go either way, doesn't matter. Points P and Q on the circle, P between D and C, so it's going to be somewhere in here, and APQ is going to be an equilateral triangle. So if I go from, that's not a straight line, if I go from A to P, and then I'm going to go to Q, so to get an equilateral triangle, it's probably going to be somewhere down here. Again, you know, much easier to get these sort of estimations right when you have a nice accurate diagram. And the other thing we're going to use throughout this question is a sort of fact that goes along with the internal external angle kind of theorems that I've talked about a lot in the Go for Gold courses and in other questions, and you should know how to calculate interior exterior angles of polygons. It's actually not the most important for this question, so I'm not going to go through it, but what is important is this idea that you can split a regular polygon into congruent isosceles triangles like this, and at the center of the diagram here we can see, okay, this was an octagon, and the angles in the middle of the octagon here, right, if this is X, there's eight of them, and they make up 360 degrees in the circle. So, you know, X here is equal to 360 degrees over 8 for the octagon, or n, where n is the number of sides in general, right? So for the octagon that's going to be 45 degrees, but in general it works for any n-sided regular shape, and x is 360 degrees over n. So we're going to use that fact in this question. Adding extra lines to diagrams is a bit of an art as well, and I'm going to add some really useful ones in here. The center of a circle is always going to be a relevant point, so let's call that O as usual, and I'm going to add in a line here to P, and a line here to A, and a line to D. And you know, there are other choices perhaps you could try to make as to where to put these lines, but these make a lot of sense. We've got isosceles triangles here because these are all radii, that could be useful. And again, before I try to write up an answer to this, I'm just going to try and get the answer, right? So first thing here, I've got this this equilateral triangle, Okay, and this is actually my first use of that theorem I was just talking about, that that angle x is 360 over n, right? Well, I've actually got that situation here. I've split it in a way into, I'm going to put a different coloured line, it's not really an important line here, but this triangle is split into 3 smaller triangles, so around the centre here, this is 360 degrees, each one of them is 120 degrees, so this is 120 degrees right here. Okay. Similarly, if I look at the octagon, right, I can split down here and down here, right, and I've got, from that picture I drew a second ago, I've got 3 of the triangles, right? I could, if I wanted to, I could keep going round and split it into 8 like this, but each of them is going to be 45 degrees, right? So when I put them together, I'm going to have 3 lots of 45 degrees here, right, which is going to be 135 degrees. So I've actually learned quite a lot here, because what I can now say is that this angle here, which I'm going to call x now, right, and that's 135 minus 120, which is 15 degrees. And what we're told is that PD is a side of an n-sided polygon that can also be inscribed in this circle, right? So I can put more lines, around, and I'm going to somehow get an n-sided polygon. So that same argument, you see, can be used again here, right? If I imagine splitting that polygon into all of these congruent triangles, then by exactly the same argument, we'll have that the number of sides is equal to 360 divided by 15, right? That's just a rearrangement of this formula to say that n is equal to 360 over x, and 360 divided by 15 is 24, and so that's the answer to this question. So actually, this is a good example of an Olympiad question that can be answered with very, very few lines of working. We've just got to be very, very clear about that working, and write that up as best we can. So let's go back to this point and try to write it up. So I think this diagram is a great one to have, and I think actually let's get rid of that 120 degrees that I've written there as well. So I think you could just write all of this, write this diagram and make that a part of your working. And you might say, let O be the center of the circle, because we haven't actually spoken about that in the question, but everything else has been named for you. And so then we have the diagram here, and we just want to go through all those arguments that we just made, right? So we're going to refer to angle POA, right? That's equal to 120 degrees, and we can just say, since PQA is equilateral, the angle at the center is 360 over 3, which is 120 degrees. Now DOA is equal to 135 degrees is a little harder to justify, and let's put a colon here and say consider angles DOC, right, COB and BOA. Now these aren't actually sort of angles on the diagram, but they'd still make sense. DOC is the one that I drew, when we had this extra, and we have these extra lines in here, right? They're exactly these angles that we were talking about. Or we can say, since A, B, C, D, all the way up to H is a regular octagon, each of these is 360 divided by 8, which is 45 degrees. So together we have DOA equals 3 times 45, which is 135 degrees, right? And then we can just say, well, obviously DOP is equal to 135 minus 120, which is 15 degrees. So we can then say n equals 360 over 15, which is equal to 24, is the answer, since DOP is is an angle, perhaps rather than the angle, is an angle at the center of the regular polygon, the one referred to in the question. So something like that. Again, you might use a few more words, hopefully your handwriting is better than mine, but that's the logic, and that's more or less, I think, a full mark answer there. Don't have to write very much at all for these questions, really, so long as it's clear and well explained, but you do have to use enough words to make it clear and well explained. So I would always, go for writing slightly more words than you think, probably, unless you're someone who's always been told that they need to make their algorithms more concise. Most students I've taught tend to fall on the side of not writing enough in these questions, but it will depend on the individual. Anyway, well done if you got that right, and I'll see you in the next question.